Have you ever just gone outside on a clear night, looked up at the stars, and just felt tiny? I think it's a feeling we all get. Here we are on this one little rock, this one species, floating in a universe that is so ridiculously big, it's hard to even wrap your head around.
And that feeling, that sense of being so small, it naturally brings up a pretty deep question, right? If we're supposed to be important, if humanity is the whole point of the exercise, then why all this? Why is the universe so unbelievably mind-bogglingly big?
And yeah, it's easy to feel pretty insignificant when you think about it that way. I mean, the sheer scale of it all can make everything we do, our entire world, feel kind of like a rounding error. And look, this isn't just some philosophical musings. For a lot of people, this is a real argument against the idea of any kind of purpose.
All right, so let's dig into that. Because this whole feeling of insignificance, it actually forms the basis of a really powerful skeptical argument. People call it the argument from waste.
What's really fascinating about this whole thing is how the argument has completely flipped on its head. I mean, it's done a total 180. For hundreds of years, the complaint used to be that the universe was too small to have been made by some infinite creator. But now the complaint is the exact opposite.
Today, it's all about waste. As physicist Victor Stenger put it so bluntly, if this whole universe was created as a special place for us, then it seems like an awful lot of space got wasted. It's a pretty direct challenge, right? If it's all about us, what's with all the extra stuff?
And he's not the only one. Even the great Stephen Hawking pointed out the same problem. Look, obviously we need our solar system to exist, but all those other galaxies, from this point of view, they just seem extra. Beautiful, for sure, but totally unnecessary.
Okay, but before we can even begin to call it waste, we first have to get a handle on the insane scale we're actually talking about. And to do that, well, we have to thank one very, very patient telescope.
So back in 2005, scientists pointed the Hubble telescope at a patch of sky that looked completely black, completely empty. I mean, this spot was so tiny, it was like holding up a single grain of sand at arm's length. And for 278 hours, that's over 11 days, it just stared into that darkness, soaking up every last photon of light. And what it found? Well, it changed everything.
In that one tiny, minuscule little window, it didn't see a couple of stars. It saw 10,000 galaxies. Not stars, galaxies. I want you to just let that sink in. 10,000 cities of stars, each with billions of suns, all packed into a spot we thought was just empty space.
Okay, so now imagine taking that one little snapshot and multiplying it across the entire night sky. When astronomers do that math, they estimate that in our observable universe, and that's just the part we can even see, there are something like 200 billion galaxies.
And it gets crazier. If you assume each of those galaxies has an average of a couple 100 billion stars, you end up with a number that is it's just nonsense to our brains. 50 billion trillion stars. That's a 5 with 22 zeros after it. It's not even a real number to us.
But here's the absolute kicker. All of it, every single one of those stars, every planet, every galaxy, everything we can see, that's only about 1% of the total stuff in the universe. The other 99% is dark matter and dark energy. So that argument about waste, it seems like a slam dunk now, doesn't it? Well, maybe not.
Because what if all that unimaginable scale, what if it isn't waste at all? What if it's actually the precise recipe you need to make life possible in the first place, to allow us to even be here asking these questions? Let's talk about this just right recipe.
Okay, so it turns out the total mass of the universe is balanced on an absolute razor's edge. If you had just a little bit less mass in the universe, gravity would be too weak. Stars couldn't cook up the heavy elements like carbon and oxygen. No building blocks for life. On the flip side, if you had a little bit more mass, fusion would go crazy, burning up all the hydrogen way too fast. Again, no life-giving elements. No life. And that same total mass also controls how fast the universe expands. If it expanded just a fraction of a percent faster from the beginning, everything would have just flown apart. Gravity would have lost the battle, and you'd get no galaxies, no stars, no planets. But if it expanded just a tiny bit slower, the whole thing would have collapsed back in on itself into a bunch of black holes billions of years ago. Either way, no us.
I mean, it is the ultimate Goldilocks story, isn't it? For us to be here, the universe couldn't be too massive, and it couldn't be too light.
It couldn't expand too fast or too slow. It had to be just right. And we're talking about a level of precision that is just staggering to think about.
So what does all this mean? It means we can go all the way back to that original question, that feeling of being small, and look at it in a completely new way. Maybe all that vastness isn't there to make us feel insignificant. Maybe it's there for a very different reason.
There's a name for this idea, cosmic fine-tuning. And it's really just the scientific observation that for life like us to even be possible, a whole bunch of things, the universe's mass, the speed of its expansion, the strength of gravity, you name it, they all had to be dialed in to an unbelievably precise, narrow range.
And when you look at it through that lens, suddenly the universe doesn't look wasteful at all. It looks necessary. All those 50 billion trillion stars, that's not extra stuff. That's the exact mass you needed to invest to get the physics just right. That giant, empty-looking canvas is actually the minimum requirement for conscious beings like us to show up and be able to see it.
And that, right there, completely flips the script. The very thing that makes us feel so small and insignificant, the sheer size of it all, could actually be the very thing that points to our significance. It's not a sign that we're a cosmic accident. It's the precondition for our existence to even be on the table. So it looks like the universe isn't big by accident. It's big by necessity. But its size is only part of the story, isn't it? Because it's not just fast, it's also incredibly, incredibly old. And that, of course, leads to the next big question. Why does the universe have to be so ancient?